Okay, so we have the gold and then we have the aluminium. Okay, so what we have here? So 85, in a sample of 85 unit made with the gold, 68 unit met the spec. Okay, so 85 here, that's your, what is 85?
N.
Sample.
N. What is 68?
X.
X.
X, number of success. So we have N, we have X here, 85, 68. Okay. Y, in a sample of 120 units made with the aluminium, 105 unit max spec. So 120,
N for aluminium.
and for aluminium, 105,
X for
X.
aluminium.
Aluminium. So find the 98% confidence interval for the difference between population proportion. So it is clear that we need to find the confidence interval between population proportion. Or maybe sometimes the question would be between the percentage of, okay, when we have like percentage of something, then it is a proportion. Okay, so population proportion of the circuit made with aluminium and gold wire. So in this question, okay, what we call the purpose of this question, okay, the purpose of this question or the purpose of this statement is to find confidence interval, okay, of circuit made with aluminium and gold. So we have to follow that. So it should be pi aluminium minus pi gold, the confidence interval. Okay, because the question mentioned aluminium first and then gold. So aluminium first population, gold is a second population. Okay. If the question like population proportion of the circle made by both wires. So it's up to you. You can do aluminium minus gold or you can do gold minus aluminium. Both will be accepted. Okay. But in this question already specific, so we have to follow. Okay. Let's say that you do gold minus aluminium. We still accept your question, but you will get penalty. Okay. 1 mark will be deduct because you didn't follow the question. Okay. That not met the spec. What does it mean? So the confidence interval that we need to construct here, it is based on the success characteristic or the failure characteristic?
Failure.
Failure characteristic, because what we have met the spec, but we need to construct confidence interval for the unit which is not met the spec. So basically we construct the confidence interval for the failure characteristic. Okay. So means that, okay, you can write your formula in this form. So what we need is a Q. Okay. So Q aluminium first, minus Q gold, okay, plus minus Z alpha over 2, QA minus QA plus QG, 1 minus QG, and A and G. Okay, you can write in this form the formula. Okay, so how to find the Q? How to find the Q?
1 minus P.
1 minus P. So P is equal to X divided by N. Then after that, you can find the Q. Q is equal to 1 minus P. Okay. Lower bound, you get? Lower bound of your CI. Anyone? Lower bound? Anyone? The lower bound value?
Zero point eight
0 point,
and 0.2.
0.2. Should you get this one?
That's the Q, 0.2.
Oh,
Negative.
okay, there's a Q. Okay, so I need the, so you should get negative 0.0481 and the upper bound 0.11981. Did you got this?
No, because I forgot to minus P, 1 minus P. So I use
Okay.
P.
So use the success characteristic lah.
Uh,
Another person, did you get this answer?
Yes, madam.
Okay. So here we have negative confidence interval. It is okay to have negative because of we calculate for the difference. Okay. So the interpretation will be different lah because we need to make sure what we have here significant to use. Okay. So give comment on the parameter estimate. So we are okay, the difference between population, proportion, of circuit by aluminium and gold. Okay, so you have to mention that not met because that's what we construct lah. That not met spread is between 4.81% more by gold wire and more by aluminium wire okay, respectively. Any question?
Madam,
Mm-hmm.
you aluminium,
Mm-hmm.
I've got 0.2.
Mm-hmm.
What is the formula for the Q exactly? Because X might divide by N, I
Mm-hmm.
got 0.8, right?
Okay,
And
that's your P.
huh?
That's your P, right?
Is my P. So 1 minus,
Okay.
right?
1 minus P is your Q.
Yes, my Q. That is QQ for aluminium means with 68 divide by 85, right, to get P, right?
Yes.
I got 0.8.
Okay.
Okay, then 1 minus by P, right?
Yes.
I got 0.2. So,
Okay.
sorry. Never mind. I
Okay.
thought the below answer is for the Q aluminium. No. Sorry.
This is a confident interval already.
Sorry. Okay, sorry.
Mm-hmm. Any more questions?
no,
Okay.
madam.
Okay. So,
Madam,
when yes,
is that the Q aluminium minus Q gold or Q gold minus Q aluminium will get the same answer?
no. I think if you do Q gold minus QA, I think it will be positive.
Oh, okay.
It will be positive. If I'm not mistaken, it will be positive value.
Okay, madam.
Hmm. What we call um, it is not like doesn't matter which one first and second you will get similar answer, no, because it is different now when we make aluminium as a first population and gold as a second population, or we make gold as a first and aluminium as a second, you will get different answer. I think if you do gold minus aluminium you will get positive, I think, but
So
you can try this.
we can try both lah, madam. With the aluminum first or gold first.
Yes, yes, that one. So means that, but in this question, we have to follow lah. We have to follow the aluminium must be the first one and the gold must be the second one. Okay, but if you have general question like I mentioned before, like for example that we have of circuit made, okay, by both wires. So kita tak mention, we don't mention which one first, then it's up to you. We can do the aluminium first and gold, or gold first and then aluminium. Both will be accepted lah. But in this case pun, in case that you do gold minus aluminium, we still accept the answer lah. But at the end, 1 mark will be deduct lah because you didn't follow the question. Okay, so what we say, this is how, if you have a proportion question, okay, this is one of the example how we twist the question for the proportion. Okay, we give you the success characteristic, in this case it's a met the spec, but we ask you to calculate the confidence interval for the failure, not met the spec. Okay, so whenever you have the proportion question, read the question carefully, what we need. Okay, whether we need confidence interval for the success or confidence interval for the failure. Okay, it could be twist like that lah for the proportion question. Okay, so the cerita dia baca soalan je lah. Okay, read the question carefully. Any more question? Okay, so we proceed to the next one. 2.6 confidence interval for the population variance and population standard deviation. Okay, so in this case, okay, in your question it will be mentioned lah whether we need confidence interval for the population variance or population standard deviation. Okay, it will be mentioned clear in your question. Okay, so similar to the proportion, you have single confidence interval, single formula for your confidence interval. Okay, so for the single sigma here, we use the chi-square distribution. Okay, so for the both similar formula, but for the sigma, we just find the square root of this value, the value for the sigma square. Okay, so chi-square distribution. Okay, so what we have for the lower bound is an upper bound of the chi-square distribution. What we have for the upper bound is a lower bound of the chi-square distribution. Okay, so it is similar to the t-task. Okay, we do have what probability value, the chi-square probability value, and also we have the degree of freedom, the nu. So nu here is a n minus 1. Okay, so the value you can find in page 38 and 39 in your statistical table on table 6. Okay, table 6 for the chi-square distribution. Okay, this notation, the macam X ni, okay, and square ni, it is a notation for the chi-square. Okay, because some student they tends to square that value lah. Okay, some students they do like, let's say that you have 1.9600 and then they square. No, this not like this lah. Okay, the chi-square, the square here is a notation of chi-square. No need to square that value lah. Okay, okay. So for the one-sided confidence interval, okay, so the variance cannot be negative value, the one that already discussed in chapter 1, variance cannot be negative value. Okay, so that's why your sigma or sigma square is start from 0 to the infinity. Okay, it starts from 0 to the infinity. When we calculate for the lower bound, the A here automatically upper bound equal to infinity. Okay, when we calculate for the upper bound, automatically lower bound equal to 0. Okay. Okay, so we go to the exercise 2.6, the number 2 here. What is the variable?
The solution rate of a certain chemical.
Dissolution rate of a certain chemical. So this is your variable, dissolution rate of a certain chemical. Okay, so we have 10 independent measurement, okay, of the dissolution rate of a certain chemical. So 10 here is a sample because this is not all from this chemical. So sample. So let's modify this question. Okay, so find the one-sided upper bound of 88 tak ada dalam buku, 95%. Okay, confident interval for the population variance of dissolution rate and then interpret your answer. Okay, so the critical value here, okay, the critical value here for all the assessment, the question that we give in assessment, the critical value must be in your statistical table. Okay, they exist in your statistical table. We don't give you the question that you need to interpolate the value to find the critical value. No, okay, it will be in your statistical table. Okay, so we need the one-sided. Okay, we try the one-sided here. Okay, so one-sided upper bound automatically lower bound equal to what? Okay, so we need for the population variance. So automatically lower bound equal to
0.
0. So 0. Okay, so we need to calculate the B value, the upper bound. So n minus 1 s square, y square, 1 minus alpha, don't need to divide by 2, the alpha. Let me check. Okay. Okay, and then no. Okay, so alpha 0.05. So we need s square. So chi square 0.95. Okay, so the nu here equal to
9.
9. Your statistical table, what we have? What we have? 0.95 with the 9. It should be
3.32.
51. So the s square, the s square value, calculate from the data given, you have
1.5909.
0.9. Okay. So we have Okay, so you have upper bound.
Six point
6.85.
eight five.
Madam, the
Yes.
S, madam, the S squared, no need to square already, right?
It is already as per, right, the value that you give here?
Yes, madam.
Yes,
Uh,
yes.
Yes, madam.
already the value of S square, so then it, oh, sorry, thank you. Pikiran I yang ke lain, okay. Thank you. So you get 6 point, what just now?
4.3.
No, madam. 4.3061.
4.3. Oh,
4.3061. Okay. And then you just interpret lah. So we have positive confidence interval, then interpretation should be similar as what we did before lah. So we are 95% confident that no need to mention the one-sided because at the end it's still we still have two value. Okay, confident that the population, should we put unit here? Hmm? Should we put unit? Do we have unit?
No.
Why no? Why no need to put the unit?
Variance got no unit.
Because variance got no unit. So variance is a dimensionless. So there is no unit to represent variance. But here, if you calculate for the sigma, unit must be there lah. Okay. So dissolution rate is between 0 and 4.3061. Any question? Okay. Okay, the last subtopic for chapter 2. Okay, confidence interval for the ratio of two population variances. Okay. So we have, like before, we have single formula. Okay, it is just S1 square divided by S2 square and then multiply with the critical value here for the both side. Okay. So which one divide by which one depends on the question. Okay, let's say that we use the previous example for the proportion. So it should be sigma aluminium divided by sigma gold lah. Similar. Okay, so how do we decide the numerator and numerator? Okay, similar as we decide which one minus which one to calculate for the difference. Okay, so for the distribution used in this case, okay, we have F distribution. Okay, so F distribution, it is similar as a chi-square. So it is a positive distribution. Okay, so that's why here we have F alpha, no 1, no 2, and here it is a F1 minus alpha, and then no 1, no 2. Okay, so it is similar lah. Okay, it is a positive what we call distribution. That's why the critical value that you have for the lower bound, it is different from the critical value that we have for the upper bound because positive distribution, similar to the chi-square. Chi-square just now we have this. Okay, but when we have Z and T, it is symmetric distribution. Okay, Z anti-symmetric distribution. So we have positive side, we have the negative side. Yeah, similar. That's why here we have Z. That's why here negative Z. Okay, because this is symmetric. Okay, that's why lower bound critical value and upper bound critical value we have similar. What we call salah tu saya cakap. Upper bound confident interval and lower bound confident interval we have similar critical value. Okay, but for the case f and chi-square we have different because they are positive distributions, so it start from 0. Okay, so for the case f distribution, okay, in our formula we need this one, lower bound and upper bound. Okay, so for the F distribution, it is a package of 3 value. We have the probability value, we have the first degree of freedom, and then we have the second degree of freedom. Okay. Okay, so no 2 here is just n2 minus 1 and no 1 here and 1 minus 1. Okay, so it is a package. When for the F distribution, okay, we have 3 value, okay, to represent the F distribution. So the value of F you can find in table 7, okay, from page 40 until the end. Okay, so which page that we need to refer depends on the probability value, the alpha value. Okay, so the limitation of our statistical table, we have limited number for the alpha. We have limited value for the alpha. Okay, so let's say that we have 90%. Okay, we have 90% here. So divide by 2 alpha 10%, divide by 2 dapat berapa? Cepat. Saya lemah matematik ni, 0.5.
0.5.
0.5.
Okay. So for the upper bound here, we need F 0.05 and then no 2 and no 1. The value of no 2 and no 1. That's upper bound. And lower bound, we need F 1 minus alpha over 2, 0.95, no 2, no 1. Okay, so the limitation of our statistical table, we don't have 0.95. Okay, so that's why it will be another formula for lower bound here, for the critical value. Okay, so that's why the critical value of the lower bound here equal to 1 over, we need 1 minus alpha over 2, that will be alpha over 2 here. We need no 2, no 1. Position will be interchanged though, so we get no 1 and no 2. Okay, that's the reason why we use this formula for the critical value of lower bound, because of the limitation of our statistical table. Okay, if you use software, that one is another story now, you can find directly. Okay, but because of we are using statistical table, then this value is not exist, then that's why we use this one. Okay, so the formula that you have in page 7, okay, go to the page 7. Okay, I assume that you have your own statistical table right now. Okay, page 7, we do have confidence interval for the ratio, the formula. Okay, and after that, you have this formula. F1 minus alpha, no 2, no 1, equal to 1 F alpha, no 1, no 2. Okay, so what we have here, it is a general formula. Okay, so we improvise based on what we need. Okay, so what we need is a F1 minus alpha over 2, no 2, so no 1. Okay, so that's why we have F alpha over 2, no 1, no 2. So we improvise. Okay, so when we go to the chapter 3 letter, then it will be different here. Okay, so you need to understand why we have this. Okay, any questions so far? Okay, let's try.
No.
Find the value.
No, madam.
Okay, let's say that we have 95% confident interval. Let's say that we have N1 equal to 12 and N2 equal to 10. Okay, so for the upper bound, we need F divide by 2. Okay, 0.025. I will write the formula. Okay, upper bound confidence interval, we need alpha over 2, nu 2, nu 1. Okay, so it is F 0.025. Nu 2 is? Nu 2 is?
9,
9. Nu 1 is?
11,
Okay. And the lower bound confidence interval, we need 1 F. Okay, let's find the value. The first one first. So, what do we have? Probability value 0.025. First degree of freedom is 9. Second degree of freedom is 11. So, we have
3.5879.
3.5879. Another one, 11.9.
3.9121.
3.9121. Okay, so 1 divided by this, then you get. Everybody got how to find the value in statistical table?
Yes, ma'am.
yes,
Okay. Okay, we go back to our, oh, not yet, the exercise. Okay. Okay, so the idea of the one-sided similar lah. Okay, because it's still variability, it is still variance. So the ratio here must be from 0 to the infinity only. Okay. Okay. So construct a 96% confident interval for the ratio of two population variances. So it is clear that we need ratio of two population variances. Okay, so please during the task read the question very carefully because previous experience, it will be quite frustrated lah when I saw the question is clear, ratio of two population variance, but what I got from my student, population mean, the confidence interval for the population mean. I don't know why they are so what we call interested with the population mean. Everything they use formula for the population mean. Okay, so please read the question carefully. Don't be so panic. Okay, because yeah, it is online test. Don't be so panic lah. Okay, so ratio of two population variances for all the roving coefficient produced by control and heated strength. What is the variable here? What is the variable?
Ratio of the population variance for all the roaming as a product.
Roving coefficient. So that's your variable. The data here is about roving coefficient. Okay, so produced by control and heated strength. So means that we need 96% CI of sigma control divided by heated. Okay, so in your formula, it is 1C square divided by 1H square. Okay, so divide by 2, 0.02. So in this case, we are lucky lah because we have similar n, then 7. What do you have?
0.1274.
0.1274, upper bound.
3.7645.
3.7.
645.
Everybody got same answer or not? Everybody got same answer?
Yes,
Yes, madam.
Any questions so far? Okay, so that's all chapter 2, guys. The end of the chapter 2. Okay, so basically you have to prepare for your test lah. Okay, so if there is no question, but you can always text me if there is any question. Okay, we proceed to the chapter 3. No questions so far? Okay. Sekejap Okay. So your test until 3.2. Okay, the hypothesis testing for the single population mean. Okay. So hypothesis testing is another method for the inferential statistic. Okay. So what we have for the confidence interval, basically in general, we estimate the value of the population. Okay. So we have population mean, we have the population proportion, we have the population variance or standard deviation. Okay. Hypothesis testing, what we do, we make our conclusion, we make an inference about the population characteristic by using this given sample data. Okay, so at the end, we draw a conclusion or we write a conclusion about the population. Okay, for example that, you are the manager. Okay, so you create a new oil. Okay, just a simple example, the new oil for the car. Okay, basically it's a fuel. Okay, so we need to test the effectiveness of that oil. Okay, so what we do, okay, it will be impossible to try on all car that we have lah. Okay, it is impossible, as I mentioned in chapter 1, it is impossible to collect the data from population. Okay, so what we do, we draw a sample. So your oil here, the new oil here, we test on sample. Okay, so let's say that we test on 100 car. Okay, 100 different car. Okay, and then we collect the data about the distance drive by the car by using the new oil. Okay, and then we compare with the data of the distance drive by the car by using the old oil. Okay, so the number of sample, as I mentioned in chapter 1, it is depends on a few factors. For example, the cost, okay, the time that you have to do that experiment. Okay, so now we assume that when we create a new oil, it's supposed to be better than the old oil. Okay, so the hypothesis that we can write, okay, the new oil supposed to be better than the old oil. Okay, and the data that we have here, the data that we collect, distance drive by car. Okay, using new oil and also using the old oil or the former oil. Okay, so the hypothesis is what we call what we assume and what we expect. Okay, what we expect. So the new oil that we create, okay, is supposed to be better than the old oil. Okay, so how the hypothesis should be? How can we write the hypothesis here? To say that the new oil better than the old oil.
Increase.
Increase because the data that we have, distance. So it should be distance drive by the car by using the new oil greater than the distance drive by the car by using the old oil. So what we have, new oil greater than old oil. Okay, this is what we expect, and at first we assume that this is a true one. Okay, this is what we expect. Okay, so you have a sample and then we calculate the test statistic, we compare with the critical value, we make our decision based on that data, and then we come to the conclusion. So in our conclusion, we conclude that, for example, new is a better than old one. So then you can plan for the rest. Maybe you can invest, okay, on the new oil. Okay, let's say that our conclusion, the new oil worse than the old oil, then you can stop the production. Okay, that's the purpose why we do the hypothesis testing. Okay, one thing, it is impossible to test on all car that we have lah. Okay, so what we do, we draw a sample and then based on the data, the sample data, we write a conclusion. So the conclusion, the end one, the conclusion that you write just now, it is represent the whole population. Okay, so that's the reason why we do the hypothesis testing. How many methods that we have for the hypothesis testing? Anyone? How many methods that we have? If you already go through all the videos, all the notes, you should know that. How many methods?
3.
3 methods. What are them? The first one?
The traditional
Traditional method. Traditional method. The second one?
Confidence interval approach.
Confident interval method or confident interval approach. The third one?
P-value approach.
Value approach. Okay. So that's why I said chapter 2 and 3, they are related to each other. Okay. When you use hypothesis testing by using confident interval approach, the confident interval, the whole chapter 2 just now. Sorry. Okay. Let me bring. Okay, so the confident interval approach means that the whole chapter 2 that we discussed just now. Okay, if you go through the, especially for the final question, okay, you can see how we relate chapter 2 and 3. Okay, one of the way is we use hypothesis testing by using confidence interval approach. So means that you have to find first the confidence interval and then apply in hypothesis testing. Okay, so basically we have three methods. So your assignment, it is about p-value approach. Okay, so for the p-value approach, we don't calculate manually. Okay, we use Microsoft Excel. Okay, so that's why for your assignment, you have to use the Microsoft Excel to get the p-value, the value of the p-value, and use that in your hypothesis testing. Okay, your assignment, it is about population mean and also difference between two population mean. Okay, so after we discuss these two subtopic, I think you can start with your assignment part 2. Okay, you can go through the videos for the hypothesis testing by using Microsoft Excel and also p-value approach lah. Okay, by your own, and then you can apply to your assignment part 2. Okay, because everything in YouTube already. Okay. So different approach, traditional approach, confidence interval approach, and also p-value approach, we have different way when we do. The difference is on decision making, what value that we compare. Okay, so we go through that one by subtopic lah. Okay, so what we have, so we have about 10 subtopic here. Okay, so what we discussed in 3.2 until 3.7, they are traditional approach. Okay, traditional approach, and then we have confidence interval, p-value, and then the errors. So when we discuss confidence interval, you will have estimation error. But when we discuss hypothesis, you will have type 1, type 2 error. Okay, so after we done with all the hypothesis, then we go to the errors. It will be more you will understand more about the errors later. Okay. So 3.1, basically the terms and definition that you have to know. What is a statistical hypothesis, the type of hypothesis, the type of test of your statistical hypothesis, whereas what is test statistic, what is rejection region, acceptance region, okay, critical value, significant level, all those things you have to know. Okay, so procedure in hypothesis testing, basically doesn't matter what method that we have, basically you have about 4 to 5 steps, okay, for your hypothesis. Okay, so we start with the formulate the hypothesis, like what we do here. This is how we formulate the hypothesis in general. Okay, and then after that we go to the test statistic. So we choose which statistic that we need to use. Okay, the test statistic that we need to use. And then the step 3, we go to the critical value. Okay, so basically we find the value in statistical table. And step 4, we go to the decision, and step 5 is your conclusion. Okay. Okay, we go just a quick review on the introduction to the hypothesis testing. Okay, so statistical hypothesis is a statement, okay, about parameter or parameters of one or more population. Okay, so when you formulate your hypothesis, it must be with notation. Okay, so notation that we use here is a parameter. You cannot use the statistic. You cannot use the S bar. You cannot use the S. So it must be parameter because the hypothesis here, it is about population, not about the sample. We use the sample data to make conclusion about the population. But your statistical hypothesis, it is about population. So I don't want to see any statistic symbol in your hypothesis. Okay, it must be parameter. Okay, so it will be either mu, okay, we have pi, we have sigma or sigma square, okay, in your hypothesis. Okay. Okay. So we have two statistical hypotheses. We have null hypothesis and also alternative hypothesis. Okay. So null hypothesis, statistical hypothesis that state an assertion about one or more population parameter. Okay. So how do we formulate the hypothesis? Okay. Let's say that we have a line number 1, 2, 3, just a simple example. Okay. We state that hash null cover from 3 and below. Hash null. So hash 1 is a statement that do not covered by hash null. Hash null is a statement that do not covered by hash 1. So they cannot be overlapped in any point. Okay, they cannot be overlapped in any point. So if we state that okay, hash null cover from 3 and below, so your hash 1 should be covered from 3 and above. They cannot be overlapped in any point. Okay, that's how we state the the hypothesis here. Okay, so your question will give you either one, whether hash null or hash 1. When we have either one, we can write the another one. Okay, so how do we know the hypothesis that we get from the question is a null hypothesis or alternative hypothesis, hash null or hash 1? Okay, it is based on the sign that we have here. Okay, the sign here. So hash null always be with equal sign. It will be either equal, it will be either less and equal, it will be either greater and equal. So it will be always with equal sign. Whenever you have equal sign, so that statement is hash null. That's how we differentiate. Okay, hash 1. Okay, the statement, the sign here with not equal sign. So you have not equal, you have less than, you have greater than. So there is no equal sign, then it is hash 1. So that's how we differentiate. Okay, the statement given in our question, hash null or hash 1. In your question, okay, mostly you will get either one. Okay, when we have either one, you can write the another one lah. Okay, so how do we write? How do we know? Because you need to understand the idea of hash null, hash 1, they are not overlap to each other. Okay, so then you can write, okay, by using the symbol lah. Okay, if you have any question, you can interrupt me anytime. Okay, so we have type of test. This is important. The type of test, it is important to, based on this, we know the alpha. I mean, what happened to the alpha? If you have one tail, then it just alpha in our critical value. If you have two tail, it will be alpha over 2. Okay, so it is important to know, for especially for the traditional method. Okay, it is important to know, okay, the type of test for the statistical hypothesis. So how do we decide that? Okay, you can memorize. Okay, it's up to you. But for me, are we based on hash null? Sorry, hash 1. The sign of your hash 1. If you have not equal like that, it will be two tail. If you have greater than, it will be right tail. If you have less than, it will be left tail. Okay. On my side, I will memorize. I mean, based on the hash 1. But it's up to you how you are going to memorize this. Okay. Okay, so this is a common phrase that we use for the hypothesis. Okay, you should be well known with all these terms. Okay, for example, here we have at most. So at most, it must be less and equal. Okay, whereas at least, so greater and equal. Okay. Okay, so all this definition, I think we will discuss during the exercise. Okay, so this is a procedure. So this is a proper conclusion statement. Okay, I will discuss through the exercise. Any questions so far?
No, madam.
Okay. Okay. Okay, apa nak cakap? Okay. 3.2. Okay, hypothesis testing for a population mean. Okay. So your test until this subtopic. Okay, so test a population mean when population variance is known or unknown. So in terms of the formula, the idea is similar as a confidence interval. Okay, it is based on the condition whether sigma is known or unknown, and if unknown, what is your n? Okay, but here we have the test statistic. So for the case mu, it will be either z test or t test. Okay, before this, it is not the task. Okay, the confidence interval. Okay, so now we have the task. Okay, this is a test statistic. We call it as a test statistic. So for the case mu, it will be either z test or t test. When you have z test, automatically the critical value is z distribution. Okay, when you have t test, automatically critical value is t distribution. We cannot compare z with the t, we cannot compare t with the z. Okay, because there are different distribution. Okay, for the hypothesis, okay, so left hand side here we have the parameter, so mu, and right hand side here it should be the value which is you can find in your question. Okay, if the population value is not in your question, then we assume that it is 0. Okay, so mu note here is a population value, or here we call hypothesized value. Okay, population mean or true mean. Okay, so it is between negative infinity to the infinity. Okay, some question we use word hypothesized value, hypothesis mean. Some question we use word population mean or true mean. Okay, so depends on the question. Okay, we go to the exercise. I'll ask you to do the number 5. So, isn't it? Have you done?
Yes, madam.
Okay. What is the variable? Okay, first, for the hypothesis testing, it is very important lah, to extract the information before we go to the form the hypothesis testing. Okay. So first step, so what is the variable? What is the variable?
Distance of rocket means
To design rocket
target.
Again,
to increase the accuracy.
it is not the variable. What is the data that we collect here?
The
Or
distance of rocket means its target.
the distance of the rocket meets its target. So means that distance rocket to its target. Okay. Because the mean, the average here, and the standard deviation here based on the rocket meets its target. So the distance of the rocket to the target. Okay. Okay, and then we go to the information. So the rocket meets its target by an average of 0.88 km with a standard deviation of 0.04 km. And then we have a new design rocket is supposed to increase the accuracy. And a random sample of the 30 locations were occupied with this new rocket to test it. So what is 0.88 here?
H0.
Mu.
It is mu. And standard deviation, the 0.04 here,
S.
again, 0.04 here.
S.
Why you said 0.88 is a mu, but 0.04 here is a S?
Rho.
It is?
Rho.
Hmm?
Population standard deviation.
Population
Rho.
standard deviation. It is sigma. So why here you said mu and here is a S? Why do you think here is a mu? Okay, one of the what we call keyword that we can use, okay, 0.88 and 0.74 here, it is before the sample of 30 location. So basically any value that mentioned before we have the sample, they are population. Okay, one of the keyword that you can use lah. Another one, this is what we call important lah. Okay. Okay, in this situation, we have the new design rocket. So this rocket supposed to be the old one or the former rocket. Okay, I have said before this, any value that represent something that already happened, the past study, the past record, what we call just now, when we discuss proportion, we have the standard treatment. Okay, it is population, something that already happened. Okay, there are population value. So here 0.88 and 0.04, they are population value. So that's why here you have mu and here you have sigma. Okay. So I will wrote here. Okay, a random sample of the 30. So 30 is your
N.
N. So these 30 rockets missed by distance with a mean of 0.76 km and standard deviation of 0.04 km. So 0.76 km here is
X bar.
S bar. Another 0.04 here,
S.
S, because it is based on 30 sample. Does the new design rocket able to increase the accuracy at 0.1% significant level? So 0.1%, that's your
Alpha.
alpha. So if alpha is not given in your question, what is alpha?
0.05.
0.05. So we use a standard one, which is 5%. Okay. So we're done with the information. Okay. All the information already extract. So we go to the hypothesis testing. Okay. So how do we know we need to construct or we need to perform the hypothesis testing? Okay. Because here we have does the new design rocket. So we need to answer that. We need to conclude that. So how to conclude that is by using hypothesis. testing. Okay, that's why here you have to perform hypothesis testing. Why not? Why it is not confidence interval? Okay, because we need to conclude something. It is not estimate. Okay, we need to conclude something. So hypothesis testing. So the first step, hypothesis. Okay, so the hypothesis is come from the purpose of, the purpose of this situation, okay, or the purpose of this question. Okay, the purpose is to test, does the new design rocket able to increase the accuracy? Okay, this is the purpose of this experiment. So that purpose is our hypothesis. Okay. So the keyword here, increase the accuracy. Okay, so based on this keyword, okay, we decide on our, what we call, the sign. Okay, but first we need to know what is our parameter for this hypothesis. Okay, accuracy. Okay, so first we already know that it is a quantitative variable because we have distance. Okay, so quantitative variable, it will be either mu or sigma that we can use. It cannot be pi because pi for the qualitative research or qualitative data. So it will be either mu or sigma. Okay. So accuracy. What value or what measure that we can use to discuss the accuracy? If we go back to the chapter 1, what measure that we use to discuss the accuracy? What is accuracy? What is accuracy? Anyone? Cepat balik buku. Chapter 1. What is accuracy? Tak ingat?
Precise, accurate and
Precise is another term. Okay. So we discuss accuracy and precision. It is under measure of, macam mana nak test ni?
central
Next week.
tendency.
What?
Central tendency.
Another answer? Okay. The test is Thursday next week. Ready or not for the test ni? Okay, so we discussed two terms, accuracy and precision. It is under measure of variation. Okay, so accuracy is how close the measured value to the target. Precision, how close the measured value to each other. Okay, so to discuss both terms, or here in this case to discuss the accuracy, basically we can use the verbability. Okay, so verbability means that if we go to the verbability, the parameter should be sigma for our hypothesis. Okay, but in this case, we cannot use the verbability. Why?
Different unit.
Different unit of what? Apa yang different unitnya? Okay. Okay. So the hypothesis is based on the word accuracy that we have just now. Okay. And another one, how we determine on the parameter is based on the information that we have. Okay, so that's why I want to discuss this exercise. Okay, you really need to understand here why we use mean, okay, in this exercise, in this question. Okay, you cannot have in mind because of this question under population mean, then I have to use a population mean. Okay, imagine that this question in your task. Okay, how you are going to decide on the parameter. Task not really, I mean, it's not tak mencabar because task you already know it is until 3.2. So basically it will be population mean. Imagine that this is in your final, So what parameter that we need to use here? Okay. So based on the information here, okay, if we go back to the accuracy, we know that we can use the probability. Okay, so probability means that it should be the sigma. And then we need to check in our information, do we have sigma value? Yes, we have the sigma value, isn't it? Okay. Do we have estimator for the sigma? Yes, we do have estimator, which is S. Betul? Betul tak? Betul?
So,
Betul kan? Okay. But if you notice, the sigma value similar to the S value. So apa maksud dia? Apa maksud sigma? Okay, apa maksud sigma kat sini? This sigma equal to the S value. What does it mean?
Same. Nothing changed.
Okay, nothing change. So maksudnya, it doesn't give any effect to the accuracy, isn't it?
Yes.
So there is no effect of the probability to discuss this accuracy. In this case, okay, to discuss the accuracy of the rocket here, probability does not give any effect because the population value is similar to the S. So does not give any effect. So similar when we discuss the chapter 1, okay, if you still remember one of the purpose of the probability, why we go to probability? One of the reason because mean similar to each other. Let's say that we discuss two data, the first mean similar to the second mean. So we have similar mean, so there's no use to use the mean. So we go to probability. So in this case, we have similar value for the sigma and S. So basically there is no effect of durability in this accuracy. So there is no use for us to use probability. That's the reason. So that's why we go to the mu. Okay, another parameter that we can consider in this case is a mu. Got it? Any question? Okay, you need to understand why it has to be mu. Okay, so mu, the sign, is supposed to increase the accuracy. Increase the accuracy. What sign that we should use here?
Greater.
Greater than. Why greater than?
increasing.
Increasing. Okay, salah lah in that case. Okay, increase the accuracy. Look at the variable. I just said just now, what is accuracy?
Close to the target.
Close to the target. So what happened to the distance? If we try to increase the accuracy,
Narrower.
apa dia? Narrower. It should be
Less than.
Closer.
less than. It should be decrease. Because we try to increase the accuracy, and accuracy is what just now? How close the measured value to the target. So how close the rocket to the target. So distance should be reduced. Distance should be decreased. So it should be less than. Okay, so this is one of the example. Whenever you have increase, it is not always greater than. You have to be careful. Okay, because we have the terms here, accuracy, one of the reason accuracy, and another one the variable that we have. It is a distance to the target. Okay, so increased accuracy, and accuracy is how close to the target. That's why it should be less than. Okay, so population mean the right hand side we have 0.88. Okay. H0 or H1?
H1.
H1.
Why H1?
Because it doesn't happen yet.
There's no equal sign. So it just less than. So H0, what is your H0? Remember that H0 cannot be overlapped to the H1. So H0 should be
Bigger.
bigger,
And equal.
bigger and equal. So greater and equal to the 0.88. Okay. So another mistake that student do, the mu note here. It should be similar to each other. You cannot have the mu note here, let's say 0.88 and here 0.80. No, tak boleh It should be similar to each other. Okay, we delete everything. Okay. Where is your claim? Where is your claim?
H1.
H1.
Okay, so claim is a hypothesis given in question. If you get H0 from the question, then claim will be at H0. If you get, in this case, we get H1 from the question, so claim at H1. Okay, it is not compulsory to state the claim. So kalau you didn't write the claim point, you still get full mark for your hypothesis here. Okay, but when we have claim, it will be easy to write the conclusion later. We can discuss the claim. Okay, because conclusion, the proper way, or the what we call scientifically, we discuss what happened to the claim. But for the conclusion later, we discuss. Okay, you can write anything that you want on the claim. It is not necessary to follow the proper statement that we have in slide. Okay. Okay, step 2 is the test statistic. Okay, so what condition that we have here? Sigma is known or unknown?
Known.
Known. So we do have sigma. So sigma is known. Okay, so automatically Z test X bar minus mu naught sigma divided by N. Okay, so your S bar 0.76 minus mu naught 0.88. Okay, sigma 0.04 and then the N 13. So you will get
Negative 16.4317.
3, 1. Okay, there's no unit for the test statistic. Okay, step 3 is to find critical value. This is case traditional method. Okay, value. So critical value is based on the type of test for your statistical hypothesis. Okay, so based on this hypothesis, what is the type of test? One, two tail, right tail, or left tail? It is
Left tail.
left tail. Okay, because you have less than here, so left tail. Okay. Okay, you can sketch. Left tail should be here. So for the Z and T, it is symmetric distribution. This is 0, this is negative side, and this is positive side. Okay, so symmetric distribution, when you have left tail, so automatically here is a negative Z alpha. So no need to divide by 2 the alpha because left tail is a one tail. So alpha is a 0.001. So negative 0.001. So find your statistical table 0.01. You have in table 4. We have
3.09.
902.
so negative 3.0902. When you have the left tail, it is compulsory to write the negative because left tail, the critical value will be negative for the Z and T distribution. Okay, so start for decision. Okay, for the traditional method, okay, for the decision, we compare the test statistic versus critical value. Okay, so I suggest you to draw this figure, okay, this figure, and then you can plot where is your Z test in this case. Okay, for the left tail case, the shaded region here, that's your rejection region. Okay, unshaded region, acceptance region. Okay, the value of critical value here is a separator between rejection and acceptance. Okay, if your test statistic fall in the rejection region, then it will be reject H null. If your test statistic fall in acceptance region, then it will be do not reject H null. So this is only answer or possible answer for the decision, whether you reject H null or whether you do not reject H null. Okay, we do not write as an accept H null. It is wrong in mathematical. Okay, it should be do not reject H null. So in this case, our Z test is a negative. Okay, negative 16. Okay, it should be less than critical value or greater than critical value. It should be in rejection region or acceptance region.
Rejection.
Rejection region. So negative 16 should be somewhere here. Okay. So if you use this figure, when you plot make sure to label, this is the Z test. Okay. So then it will be understood that your Z test is in rejection region. So Z test less than. So before we do the decision, you have to write the comparison first. So in this case, Z test less than negative 0.01, then decision should be
Reject.
Reject the hash null.
okay. So the benefit, if you have this figure, let's say that you made a mistake here, the comparison. I will check your figure. Okay, if you plot correctly, so you might get mark here and the mark here lah. Okay, if the comparison is wrong. Okay, let's say that there is no figure and then the comparison is wrong, so both will be wrong. Okay, so this is the advantage lah. If you draw a figure correctly, you label correctly, and then your comparison incorrect, for example. Okay, you do a mistake on the comparison, I will consider the figure that you have here. Okay, so you will get mark, some mark lah. Okay, it's just not zero. Not bad. Okay, so reject H null, step 5, conclusion. So basically the conclusion, we write what happened to the claim. Okay, so we reject hash null means that we say no to the hash null. So we support the or we accept the hash 1. Okay, and then because of the claim at hash 1, so means that we support or not the claim here?
Support.
We support the
Yes.
claim. So you can write that in your conclusion. Okay, because proper way is to discuss what happened to the claim. Okay, so at alpha 0.001, okay, alpha is very important in your conclusion, compulsory to write in conclusion, because if we change the alpha here, critical value will be different and decision could be different. So this conclusion that we made for this population only valid for alpha 0.001. Okay, so at alpha 0.01, there is to support the claim that new rocket increase accuracy. Okay, or you can write there is not enough evidence to reject. Also correct. Or you can answer directly the question here. Does the new design rocket able to increase the accuracy? You can write also correct. It's up to you. As I said, it's up to you. For your conclusion, you can write anything as long as you do accept or you do support hypothesis that's supposed to be based on your decision. There's no right, it is okay not to follow the proper statement that we have in slide. Okay, any question? I forget to apa? I forget to create the attendance in Google Classroom. Okay, quite busy today. I will do tomorrow lah for the attendance. Any question for today?
No, madam.
Okay. So I repeat, there's no virtual class on Wednesday next week. Okay. I will inform later about Monday. Okay. But if we do the class on Monday, I just want to discuss your test. We can discuss here what you don't understand, or you can do the past year or the past semester for the test question from the past semester. We can discuss. Okay, the subtopic for the next week we bring to the next week. So maybe the next 2 week we will have class on Monday and also Wednesday lah. Okay, to discuss, to cover the subtopic for next week. Okay, because I don't want to disturb you when you preparing for the test lah. Okay, so tak apa kot, good luck for the test lah. Any question?
No, madam.
Okay, so thank you for today. That's all for today. You can always text me if you have any question regarding the test. Okay, I will try my best to respond as soon as possible. Okay, thank you, class. See you later.
Right, madam. Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.